All right, so 6.6 part 3. Looking at this first problem, we're trying to evaluate. How do we normally evaluate this kind of problem? Just do what? Set it equal to x, and then we rewrite it as a logarithm. Okay, that's how we normally do it. But the problem with this is that we don't have like bases. See, look, if I think ahead about this, if I'm trying to rewrite this, this isn't what I would do, but just kind of watch for a minute. If I set this equal to x, it would become log base 81 of x equals log base 3 of 2. Do you see how that's a problem? Because we don't have like bases, and we need to have like bases. So what we want to be doing is we want to think ahead. This is log base 81, but this is log base 3. So we want this base to be the same as that one. So how can I rewrite 81 so that I do have that same base? Marcella? 3 to the 4th, right. So I'm going to rewrite 81 as 3 to the 4th. That's another name for 81. And then raise to the log base 3 of 2. And I'm still going to say equals x. All right? Remember our pattern, that if we have b to the a equals c, it's the same thing as log base b of c equals a. We keep using that rule over and over. So here's b, right here is b, right here is a, and right here is c. And I want to rewrite it as a log. So I'm going to do log, but before I write it as the base of 3 to the 4th, remember how if I have a power to a power, I can just multiply those? Everybody remember that? We can just multiply those? So what I can do then is I can just get rid of these parentheses. And I can just think of it as 3 to the 4 log base 3 of 2. See, I can think of it as this, like that instead. So now it's going to be log, find the base, swirl it around, equals this. And now see if you can figure out what that would evaluate to be, what that would simplify to be. Does anybody think they know? Tori, what do you think?
16.
16? Marcella, is that what you got?
No.
You didn't? Anybody else get 16? No? 16 is right. Okay? Here's the reason why. This coefficient can be thought of also as an exponent on the 2. So now we're going to have log base 3 of x equals log base 3 of 2 to the 4th. What's 2 to the 4th? So therefore, this has to be 16. Now, here's something I'm going to stress. I do not write x equals 16. In the original problem, is there an x in the original problem? No. We just put the x there ourselves. So we don't want to say x equals. That would be confusing. We're actually saying this answer is just 16. Don't put x equals. All right. Next one I want you to do on your own, but I'll kind of help you to get started. Think ahead. This is going to be our base. This is going to be on the other side. I want this base to be the same as that base. Okay? So what am I going to need this 8 to be rewritten with the base of? Karen?
Oh, I had a question.
Okay, go ahead.
What does OYO mean?
On your own.
Oh.
Yes, Justin. So I can rewrite 8 as 2 to the 3rd, and then if that's 2 to the 3rd, the 3 gets multiplied by this. That's as much as I'm going to do. The rest is on your own. got it, raise your hand. All right, I've seen a lot of people get it. So what we're going to do is we're going to set this equal to x. We're going to do, now here's our base. So it's log base 2 of x is equal to 3 log base 2 of 5. What happens to the coefficient? It becomes what? What, guys? What's the coefficient become? Exponent. And so then we have log base 2, x would have to be 5 to the third. 5 to the third is 125, and so that's what that's the same as. All right? You could, if this were on your test, you could just type that into your calculator too. But I don't even know if that would be easier, really. I think this is just as quick and easy as trying to type that in. Okay, let's go to number 3. Number 3, we're actually going to wait on. That's one of those that takes a long time to do, so we'll come back to that if we have time. Let's take a look at number 4 first. Looking at number 4, can I set 3x minus 4 equal to 1?
No.
Why not?
Because 2 and 5 are not the same.
We do not have the same base, so we cannot do that. Can anybody think of something we could do? Justin?
Maybe change it from 2 to the power of log base 1 equals 3x minus 1.
You could do that, yeah, you could. But can we do something with that log base 5 of 1 before we do that? What do you think, Tori?
Log 1 over log 5.
Yep, you could do that. Yep, but there's even a better thing to do. Taylor?
Are you going to make log base 5 to 1 equals 0?
Yes, that's what we need. See, look, guys, anytime we see this, think 5 to what power would give us 1? 0. So another name for this log base 5 of 1 is just 0. Isn't that going to make things a lot easier if that's just a 0? So now we're going to have log base 2 of 3x minus 4 equals 0. That's the trick. If you can evaluate this, do it. And now it should be pretty easy to finish. Go ahead and do it on your own. See if you can get it. Good. Okay, a lot of people have it. Let's take a look at it now. So we have to swirl this around to create it so that it would be exponential. So it's 2 to the 0 equals 3x minus 4, written as an exponential form. So this is 1. We add the 4, we get 5. We divide by the 3, we get 5/3. Good job. I saw a lot of people get that. All right, looking now to simplify when we have exponents. Look at numbers 5 and 6. They look nearly identical. What's the difference? Parentheses is the only difference. Doesn't really make that big a deal when we have parentheses. Yes, it does. On number 5, I'm going to help you with the first step. 3 divided by 4. All we're going to do is write that as a fraction. 3 divided by 4. Now to the negative 2 power. So each one of those has to be raised to the negative 2. How else can we get rid of the negative 2? Flip it over, right? Okay. Go ahead and do it. Tom, what did you get?
I got 16 over 9.
That is correct. All right, everybody get that? Just flip it over and then square it. All right, so let's look at the difference between that and the next one. On the next one, it's going to be 3 and then divided by 4 to the negative 2. That does not change to a positive exponent. The problem is 3 divided by 4 to the negative 2. Okay, now I want you to simplify that. That's how you get started. But it doesn't matter because it's going to end up in the same thing. I think this. Alright, so what did you guys get? What do we do to make this a positive exponent, guys? Where is it going to go? It's going to go to the top, right, to make it positive 2. And so then what's the answer going to be? 48. Now, just so I'm saying, don't you have to do 4 to the negative 2 first? Well, look at this. If I do 3 divided by, what is 4 to the negative 2? 1/16. What do I do if I'm dividing? I have to multiply by the, wouldn't that be the same thing then? See what I'm saying? Okay, good. All right, let's come down here to the 2 tough ones. Okay, number 7. Similar concepts. 1 has parentheses around both. Number 8 has parentheses around both. Number 7 just has parentheses around 1. Okay? Here's what people forget to do. They forget that this is 9 to the negative 1/2. They always forget to do the 9. They do the x, but they forget the 9. See, 9 is to the first power. So I have to multiply 1 times negative 1/2. So it's going to be 9 to the negative 1/2. What's x going to be to now? Multiply them, what do you get? 3/2. And then we have times 3x to the 1/2. Okay, you guys simplify that now. All right, 9 to the negative 1/2, what is it? 1/3. The reason why, this means the square root of 9, and then the negative makes it go to the denominator. And then we have x to the 3 halves, and we have this. Okay, Emma, did you get it? What is it?
Oh, wait, after, and then, now, I,
No, sure. Okay, what's 1/3 times 3? 3 over 3. So this would be 1. And then what do we do when the bases are alike? What do we do with the exponents? Add them. So what's 3 halves plus 1 half?
it's just two.
2. So we could just x squared. Okay? How many people got x squared? All right, pretty good. Okay, let's take a look at number 8 now. One step at a time. Does the 5 have to go to the 1/4 power? Yes, it does, because it's in parentheses. So we have 5 to the 1/4. X, what do we have to do with these two things?
Multiply.
Multiply, what do we get?
-1.
Good. Now we have divided by. Okay, what is 5? Does the 5 have to go to the -3/4?
Yeah.
Yes. And what happens to the x then if we multiply those? -3. All right, let's see what you can do. You know what? Let me help you with this. This has a kind of a trick to it too. Because this is really still in parentheses. Do you see what I mean? Because it's this whole quantity that has to get divided. So this is really still in parentheses. So let me do just one more step with you. We would have 5 to the 1/4, x to the -1, divided by 5 to the -3/4, x to the -3. We'll do that step and now finish it. All right, who got 5x squared? All right, who wants to explain how they got it? All right, go ahead, Karen.
So I took 5 to the 1/4 and divided -3/4. And because they have the same base, you can just subtract the exponents. And when you subtract a negative, you just add, so then the exponent becomes 5 to the first. And then the same thing with the x, just subtract, and then you add the 3 to the -1 and get 2 with x squared.
Good job. And you know what I like to do, guys? I always just make these positive. So the way I did it was I took this up to the top. I thought of it that way, and I took this up to the top, and then it didn't become negative. And then I said bases alike, add the exponents, bases alike, add the exponents. Same thing. It'll always work as long as you follow the correct rules. Okay, guys, I'm going to go back and do that other one. I don't even want you to write it down, though. I just want you to watch and focus. Sometimes when you try to write, it just gets too difficult. And these problems take a while. Okay, number 3. How did I show this class to do it? Did I tell you to rewrite it as a log or take the log of both sides? Rewrite it as a log? Okay. All right, so just watch. So this is going to now be thought of as a to the b equals c. That's what it is. So it's now going to turn into log base a of c equals b. So it's going to be log base a of c equals b, which is that exponent. All right, so now what does this exponent turn into for the log?
Goes in front.
Goes in front. It's now 2x plus 3 log base 5 of 3 equals x minus 1. I have to distribute this through. So I have 2x log base 5 of 3 plus 3 log base 5 of 3 equals x minus 1. All right, so what I want to do now is I have to get all the x's on the same side. So these two have x's, and these two do not have x's. So everything with x's has to be on the same side. So I'm going to have 2x log base 5 of 3 minus x equals negative 1 minus 3 log base 5 of 3. Okay? Now I want to get x by itself, and these are not like terms. When that happens, when they're not like terms, I have to factor out the x. And I have 2 log base 5 of 3. What's x divided by x?
1.
1. Okay, now I have x times something. How do I get rid of multiplication?
Division.
Division. So I'm going to divide both sides by that. And I know that was a quick explanation, but that would be our answer right there. Now, another way I could write it would be this coefficient can become what? Exponent. So I could also say the answer is negative 1 minus log base 5 of 27 over, and then what could this be written as? Log base 5 of what?
9.
9. Log base 5 of 9 minus 1. That would be a good answer. That would be an exact answer for that. Do you feel like you could go through that on your own? I mean, I know I did it very quickly, but that was just to kind of get you thinking about the process. The details you'll figure out on your own, but just understanding the big concept there of rewriting it as a log, going through, getting those x's together, and the constants together. All right, we're going to stop there. Your homework is worksheet 6.6, part 3. This is going to be on Canvas as a PDF, so you could use Kami, or I have hard copies over here if you'd rather just have a paper copy.